today we're going to be finishing up our definitions, and then I've got some worksheets which you're going to hand in for marks, our first marks of the year. Will be great. So you can double check if you've got, I've color coded everything there. Again, things are like terms. They have to have the same variables with the same exponents. So like, I'm just going to highlight one here. I'm going to highlight this one, zxy squared, which I had originally circled in blue, and I'm going to highlight this one. Those two highlighted ones have the same variables. They have an x, a y, and a z. They have the same exponent. Their exponent is 2. They are not alike. They are not alike because the 2 is with the y, and the other one, the exponent of the 2, is with the x. So those highlighted ones are not alike. I'm going to take those highlights away. They are not alike because the exponent has to go with the same variable. Okay, so we have a couple more definitions to go through. Yes.
So is the exponent and the number, is the variable number that has to be true?
It has to be with the same one, yes. So that exponent is with the y. So this one and this one are not alike.
Why?
So this one, the y has an exponent 2, and this one, the x has an exponent 2. So this one and this one are alike, and this one and this one are alike.
Oh,
Not all
that's
four.
fine.
Yeah. So anytime you put a group of terms together with adding and subtracting or multiplying, that makes an expression. An equation has an equal sign. And we're going to do a whole unit on equations. In fact, mathematics loves solving equations. So when you have one expression that's equal to another expression, you have an equation. Simplification. We are going to find out in polynomials that if you have like terms, we will add and subtract them and put them together. So if I have 2x and it says plus 4x, first of all, can you see that those two terms, this one and this one, that they're like terms? They're like terms because the letters are the same with the same exponents. And when you have like terms, the x just represents something. If you have two x's, if you actually had 2 letter x's, and you added another 4 letter x's, how many letter x's would you have in total? 6. It's not actually crazy rocket science or anything. It probably makes a lot of sense.
Wait, so how 6?
Because 2 x's plus 4 x's would give you 6 x's. 2 oranges plus 4 oranges gives you 6 oranges. 2 desks plus 4 desks gives you 6 desks.
So we're just adding it.
Right? But 2 desks plus 4 pens doesn't give me 6 desks. Right? But that's a common mistake happening in math. It's so easy once I use regular words. Like, so you just wrote here that 2 desks plus 4 pencils equals 6 desks. You're crazy. That makes no sense whatsoever. But sometimes we'll have students go, 2x plus 4y equals 6x. This is completely wrong. It doesn't make sense. Just like 2 desks plus 4 pencils equals 6 desks. That's what this is basically saying. But in algebra, we start using letters as abstract ideas, as variables, to say it could equal a number. And what could that be? Okay. Then substitution. Substitution is when you replace the variable with a given value. For example, if I tell you x is 3, what's 2x equal to?
5.
X would be 3. What is in between when we switch them together? Adding, subtracting, multiplying, or dividing? Times them. So 2 x's would be 6. What would 4 x's be? 12. What would 6x's be?
18.
18. Check this out. When we did like terms, and I did 2x plus 4x, did I get that there was 6x? Check out with numbers. If I do 6 plus 12, do I get 18?
Yeah.
Yeah. So the cool thing about algebra is that the math that you're doing with algebra, with variables, is connected to regular math. And it makes sense whether you're using numbers or whether you're using variables. So, for each of these, let's check our definitions. If you have 3x squared minus y minus 1, here's the definition you need to know, and this is how it'll be asked on quizzes and tests to see if you know a definition. What is the exponent of the first term? So there's two words in here that we had in our definitions. You have to know what a term is, and you have to know what an exponent is.
It would be the 2, right?
It would be, the answer would be the 2. So if you know the definitions, you'll write the right number down. If you don't know the definitions, you'd be guessing.
Yeah.
Okay? How do we know this? Well, this has 1, 2, 3 terms. Adding and subtracting separates things into terms. Oh, I answered the second question. I didn't want to give you away the answer. You see, I answered that. Oh, how many terms are there?
3.
3. What do we call a polynomial with 3 terms?
Trinomial.
Trinomial. And remember that tri means 3. So then we can
Just
answer
out of
these
curiosity, instead of saying like writing out the whole thing, do you say try or anything like that? Like
No,
it's-
you write out the whole thing. Trinomials. 3 terms. What is the coefficient of the second term? Oh, I believe Dayton was the last volunteer. He gets to pick someone. Or did he pick someone already? No, you did pick someone. You picked Logan.
Me?
And did you pick anyone?
No.
Oh, so it's Logan's turn to pick. If I ask, what is the coefficient of the second term? Who are you going to pick? Make him sweat a little bit.
They won't.
Come on.
There we go.
What are the different coefficients?
So what does coefficients mean again? That is the number in front. And for this one, you're going to probably have to use your math goggles a little bit. What's the number in front of the variable on the second term?
1. Wait. 1, yeah.
1 is the number in front when you can't see it. And with a minus sign, the
Negative.
answer would be -1. So there are some teachers who will always teach rewriting this with, I don't, it looks a little bit confusing when you change. Adding a negative is same as subtracting. But then they say maybe it helps you see that the coefficient is -1 better. I'm not sure. I just remember that if there's a negative sign, it's always included with the coefficient. If you're subtracting, your coefficient is negative. If you're adding, your coefficient is positive. I find that easier, but some people like to write it with plus a negative there. Okay, so there it is, the coefficient of the second term. We got that one, -1. Abel, you get to pick the next volunteer, the constant term. Oh, I like that little shake of the head. He's like, don't pick me. Oh yeah, Ruben? Okay, Ruben. The constant term. ¿Sabes qué es constant? Que es el número sin letra, sin variable. Sí. ¿Qué número es?
El número negativo,
Yeah. And in English?
-1.
-1. Perfect. Right? So one of our plans this year is to not only learn the math, but for all of us who English is our second language, to get even better at H. The variables. Ruben, you get to pick. Puedes elegir. Alguien.
Daniel.
Daniel, what are the variables in this one? So here's our example. We've got 3x squared minus y minus 1. We're checking our definitions. Which are the variables?
What is -1 or something?
Is it going to be a number or is it going to be a letter when we talk about variables? Right? So again, this is where, oh, I have to check my definition. And these definitions you might want to put on your cheat sheet for this unit. A variable is a letter that represents a number. So what letters do we have in this one, Daniel? And? X and Y. I have to space it out because I remember one year I wrote this. I wrote X and Y like this. Someone put up their hand and said, "Who's Andy?" I was like, "What? Who's Andy?" And I'm like, what do you mean?" "Well, you have X, Andy." I was like, okay, so now I have an extra space in between. X and Y are variables. Okay, Daniel, you get to pick the next person. What is the exponent of the second term? Daniel, who are you going to pick? Stacy?
Okay.
Okay.
Is
Mike?
it 2?
Okay, the second term, which color is the second one? Are we looking at the green, the blue, or the red one?
The second one's Y.
The second one's the Y, that's the blue one. So you're looking for the exponent. And yesterday we talked about putting math goggles on, because sometimes when we put our math goggles on, we like see the number 1 in front, we see the number 1 as the exponent.
What's the exponent?
So what's the exponent? It's the,
Negative 1?
it's the exponent is the little number. And you have to kind of put on your math goggles to see that one.
Wait,
Okay.
Yeah,
would it be -1 or just 1?
it would be +1.
+1?
Yeah, -1 would be the coefficient. That's the number in front. Exponent is what is the small number written above, and that would be a +1. What is the degree of the whole polynomial? You got to pick the next volunteer.
Savannah. I'll pick Savannah.
Savannah. Oh, you weren't here yesterday.
Oh.
So you have no idea what degree is yet, but you're going to watch the video and you're going to get caught up. So we go back to our definitions. We find out the degree of a term. We find out the degree of the term by looking at the exponents. So in the green term, what's the exponent in the green term?
What?
Is it the 3 or the 2?
2.
So the exponent is a 2. So we would say the degree of the first term is 2. What's the exponent in the second one? The little number. So we've got a -1 out in front, we've got a y, and we've got a little number 1. That little number 1 is the exponent. So the degree of the second term is 1. And whenever there's no variables, the degree of the third term is 0. Now, when you want to find the degree of a whole polynomial,
You add them all together?
do you add them all together, or do you take the biggest one?
Add them all together.
Right, and that is the wrong answer.
Wrong answer.
You picked the biggest one. So the answer, the biggest of those 3 is the 2. So the answer of this one, the degree of this polynomial is 2. Okay, one more example, then we're going to end our video here and do an assignment to hand in.
Right now,
Class ends at
10:45.
10:45. Yep. So we're going to have 10 minutes to work on stuff after this. Get as much done as possible. Write a trinomial with degree 5 that has 4 variables and a constant. There's many right answers to this.
If
If it's a trinomial, Does it make sense that you're going to have three things? I'm going to put 3 spaces right there. What do I need? I need a constant. What's a constant?
A number that goes there.
A number with no variables. Pick a favorite number. Pick a number, favorite number. 5. So we could put a 5 in here, and I can put a check mark above that. I can put a check mark above trinomial. So far I've got 2 things done. What do I need for variables? 4 variables. What letters do you want to use?
5.
X, Y? X, Y, A, and B. Okay. Now they have to go in these ones, right? Do you want them all in both? Like, you want X's and Y's in the first one, A's and B's in the second?
Yep.
Okay. So X and Y and A and B. We now can check off. We did 4 variables. Does this have a degree of 5?
For it, yeah.
What's the degree of this one? Add the exponents here,
2.
you get 2. Add the exponents there, you get 2. What's the biggest number?
5.
2.
Or 2.
It needs to be 5. What exponents should I add?
3.
On which one? You want? I can add an exponent of 3. Where? On the X, the Y, the A, or the B?
Y.
Okay. So if I put an exponent of 3 on the Y, oh, I'll do it in black. What's the degree of this one now? Add the exponents. 3 plus math goggles, there'd be a 1 there. That'd be a 4. Do we have a degree of 5 yet?
Okay, make it 4.
We could make it 4, or you could add to the X. What could I add to the X?
2.
A 2. Now I have a degree of 5. Perfect. This would be a complete answer, and it would be right. Do you have options? Could you put a 2 out in front here? Absolutely. If you really like the number 17, you could put a 17 there. It didn't say you couldn't. But you see how I went through each of the steps and tried to add the definition to the equation. So those will be things you'll be asked to do. Okay, we're going to end our video here.